When people start a woodworking project, the process often looks simple from the outside. A plan exists, materials are available, and tools are within reach. In daily practice, though, much of the building process depends on interpretation. Measurements are read, parts are cut, and pieces are assembled based on drawings or written steps. This creates a hidden dependency on clarity. The entire outcome depends on how accurately instructions translate into physical parts. In everyday home workshops, woodworking usually operates through a chain of steps. A person finds a design idea, locates a plan, buys materials, and begins cutting. Each stage relies on information being complete and accurate. If a dimension is unclear, a joint placement is not specified, or a sequence of steps is missing, the builder must fill the gap. That gap becomes guesswork. It may seem minor at first, but small uncertainties accumulate across the build. This information chain has several links. Plans may come from books, magazines, websites, or shared drawings. Materials come from lumber suppliers. Tools translate measurements into cuts. Assembly turns parts into structure. If any link in the information side of that chain is incomplete, the physical outcome changes. A board cut slightly short cannot be lengthened. A misaligned joint affects the rest of the structure. Time, material, and effort are all tied to the accuracy of early steps. When this chain is interrupted by missing detail, the builder often switches from following instructions to making assumptions. They may estimate a dimension, choose a joint location by eye, or adjust parts to compensate. These decisions create variability. Sometimes the result works, but it depends heavily on experience. For beginners and intermediate builders, this can lead to rework, wasted materials, and projects that do not match the original design. Because of this, different categories of solutions have developed to reduce reliance on guesswork. One approach is skill-based learning. Builders study joinery, measurement techniques, and layout methods so they can interpret incomplete plans more accurately. This builds long-term ability but takes time and practice. It shifts dependency from instructions to personal experience. Another approach is tool-based precision. Jigs, guides, and measurement devices help control cuts and align parts. These tools reduce physical error, but they do not solve missing information. If a plan does not specify where a component should be placed, even precise tools cannot provide that answer. A third category involves documentation systems. These are formats where projects are broken into detailed steps, with exact measurements, material lists, and visual diagrams. Instead of expecting the builder to infer missing pieces, the documentation attempts to specify each stage. This approach focuses on reducing information gaps rather than increasing skill or tool complexity. Its strength lies in structure and repeatability. Its limitation is that the quality depends entirely on how thoroughly the documentation is prepared. Within this broader category of documentation systems, there is an accessible format often used at the household scale. This format centers on structured build plans. These plans present a project as a sequence of defined components and steps. Materials are listed with quantities. Dimensions are provided for each part. Assembly layouts show how pieces connect. The goal is to shorten the distance between the drawing and the finished object. Functionally, this format works in a clear sequence. First, the builder reviews the materials list and gathers the required components. Next, parts are cut according to specified dimensions. Because measurements are defined in advance, cutting follows a known set of targets rather than estimates. After cutting, parts are arranged using layout diagrams that show orientation and position. Assembly follows a step order, which reduces uncertainty about what should be joined first and how later steps depend on earlier ones. This format differs from informal instructions in one key way. It treats the project as a system of predefined relationships rather than a loose concept. Each piece has a role, a size, and a place. When documentation is structured this way, the builder's task becomes execution rather than interpretation. The chain between information and physical structure becomes shorter and more direct. In some cases, this format appears as a finished product, such as pre-cut kits, where parts are already sized. In other cases, it appears as a build-from-plan system. In that situation, the builder still cuts and assembles everything, but the guide provides the structural blueprint. These guides typically include a materials list that specifies lumber types and quantities, an assembly layout that shows how parts fit together, and dimensional drawings for each component. Some may also show hardware placement or structural reinforcement points. The focus remains on how pieces connect and in what order. At the household level, this format supports repeatability. If a project is built once using clear documentation, it can be built again with similar results. This reduces reliance on memory or improvisation. It also makes it easier to pause and resume work, since the next step is defined rather than dependent on recall. This approach can be useful in several situations. It fits people working in limited spaces, where mistakes in material use are harder to absorb. It suits those who build occasionally and do not maintain constant hands-on experience. It also supports learners who want to focus on technique while reducing uncertainty about dimensions and layout. At the same time, structured plans do not replace other systems. Skills still matter. Tools still affect accuracy. The documentation layer acts as an additional structure that reduces the information gap. Instead of removing the need for craftsmanship, it stabilizes the starting point. By shortening the chain between idea and execution, this format reduces dependency on guesswork. The builder relies less on assumptions and more on defined relationships between parts. The project becomes a series of controlled steps rather than a sequence of open decisions. For those researching this approach, structured guides exist that document full build formats step by step. These references outline materials, dimensions, and assembly sequences in detail. One example of such a format reference is commonly shared in the video description for viewers who want to examine how this system is organized in practice.